So today we're going to learn Unit 3, Lesson 8, solving logarithmic equations. So first, let's have a look at learning goals. Learning goals for today is simple. After this lesson, you will be able to solve logarithmic equations and solve problems that involve logarithmic equations. First of all, let's have a look at some key concepts that related to solving the logarithmic equations. So first of all, it is possible to solve an equation involving logarithmics by expressing both sides as a logarithm of the same base. For example, if a is equal to b, then log base 10 of a is also equal to log base 10 of b, right? And if log base 10 of a equals log base 10 of b, then a equals b, right? Second, when a quadratic equation is obtained, methods such as factoring or applying the quadratic formula may be helpful. Third, some algebraic methods of solving logarithmic equations lead to extra roots, which are not valid solutions to the original equation. So always pay attention to the domain. Never change the domain, okay? All right, so let's use some example questions to illustrate these concepts. And let's have a look at how do we solve logarithmic equations or problems that involves logarithmic equations. So first of all, let's have a look at these two simple logarithmic equations. I'll give you 10 minutes to solve these equations by yourself, right? Okay, let's have a look at the solutions. First, question A. We can solve this question by using the definition of logarithms, right? That is to express logarithm to a exponential. So log base 10 of x plus 4 equals 1. This means x plus 4 is actually 10 raised to the power of 1, right? Which means x is 10 minus 4. Therefore, x is 6, right? Okay, second one, log base 5 of 2x minus 3 is 2. That means log base 5 of 2x minus 3 is actually log base 5 of 25, right? Because log base 5 of 25 is 2. Therefore, 2x minus 3 equals 25. That means 2x equals 28. That means x equals 14, okay? All right, so you can also check the solution with explanations on this lecture slides. Now let's have a look at another question. Apply factoring strategy to solve questions. Solve, identify, and reject any extraneous roots. So here are two equations that involve logarithms. First of all, I'll give you 10 minutes to think about these questions, and after that, we'll have a look at the solution together, okay? All right, let's have a look at the solutions together. So for question A, note here the original expression is equivalent to, you can move the term on the right to the left, right? Log base 10 of x minus 1 plus log base 10 of x plus 2, and move the minus 1 here to the right, equals 1. And this is equivalent to, remember that we can apply the product laws of logarithms. So this is equivalent to the log base 10 of product of the two terms equals log base 10 of 10, right? But remember that you need to specify the domain. Do not change the domain. First of all, x minus 1 needs to be greater than 0, and x plus 2 also needs to be greater than 0, right? And this is equivalent to, first of all, x minus 1 times x plus 2 equals 10. Second, x greater than 1 and x greater than minus 2 can be combined to x greater than minus 1, right? And this is equivalent to x squared plus x minus 2 minus 10 equals 0, and x is greater than 1, right? And this is equivalent to x plus x minus 12, right? So x minus 4, and then x plus 3 equals 0, and x is greater than 1. And this is equivalent to x is either 4 or x is minus 3, and x should be greater than 1. And of course, the final solution is x equals 4. We need to discard that x is minus 3, because x minus 3 will make the number here and number here be negative, which violates the domain, right? Sorry, made a mistake. This should be a positive sign here, and negative 3 here. So the final solution is minus 4 positive 3. And of course, we need to discard x being minus 4. Only keep x being 3. X being 3 is the only solution, right? All right, let's have a look at question B. So question B is equivalent, the equation in question B is equivalent to, first of all, log base 10 of x squared plus 48x raised to the power of 2/3, right? And this is log base 10 of 10 raised to 2/3. Therefore, first of all, we need to ensure that the domain is, this number here is above 0, and x squared plus 48x equals 10. Sorry, made a mistake here again. This should be 1/3, not 2/3. Okay, 1/3. And we don't need to change the expression on the right. The expression on the right should be 2/3, right? Okay, so first of all, we need to ensure that x squared plus 48 is greater than 0, and then we can put the exponent in front. This equals 2/3, right? And this is equivalent to x times x plus 48 greater than 0, and then log base 10 of x squared plus 48x is 2, right? Therefore, this is equivalent to x is either less than 0 or x is greater than minus 40, x is less than minus 48, because this is a quadratic expression, right? It opens up and has two roots, minus 48 and 0. The interval that corresponds to the function value greater than 0 is x is either less than minus 48 or x is above 0, right? And second expression is equivalent to x squared plus 48x is 100, right? And this is equivalent to x is less than 48 or x is greater than 0, and x plus 50 times x minus 2 equals 0. Therefore, x is either minus 50 or x is 2, right? And remember that x needs to be minus 48 or x is greater than 0. So neither of these solutions violates the domain, so we can accept both of them. Okay. Have a look at the solution, and you can also check the solution with explanations on this lecture slides. If you have any questions, please let me know, okay? All right, so let's have a look at another example question. Find the exact solution of the equation log base 10x plus log base 10 of x minus 4 equals 1. Again, I'll give you 10 minutes to think about this question by yourself first. All right, let's have a look at the solutions together. All right, so first of all, according to the product laws of logarithms, the original expression is equivalent to log base 10 of the product of x and x minus 4, right? And the right side can be rewritten as log base 10 of 10, right? Because log base 10 of 10 is 1. So that means, forgot the domain. And if you want to use the equivalent sign here, you should control the domain should be exactly the same as the original expression, right? So first of all, x needs to be greater than 0, and also x minus 4 is also greater than 0, right? Okay, so this is further equivalent to x times x minus 4 equals 10, and x is greater than 0 and x is greater than 4, right? And this is equivalent to x squared minus 4x minus 10 equals 0, and then x is greater than 0 and x is greater than 4. This can be combined to x is greater than 4, right? Okay, so now we need to solve the asterisk here. This is a quadratic equation, right? So we can just directly use the quadratic equation formula, which means there are two solutions. One of them is 4 plus square root of 16 minus 4 by 1 by minus 10 over 2, right? And this is 4 plus twice of square root of 15, right? Over 2, which is 2 plus square root of 15. And also note that the domain states that x should be greater than 0. And if you check this number is apparently greater than 0, so this is accepted. accepted. And there is another solution, which is 4 minus 16 minus 4 by minus 10 over 2, right? And this equals 4 minus twice of square root of 15 over 2, which equals 2 minus square root of 15, right? Apparently, square root of 15 is greater than 2, so 2 minus a number that is greater than 2 is a positive number. This violates the domain, which states that x should be greater than 4, right? So this is discarded. Therefore, there is only one solution, which is 2 plus square root of 15, right? Okay, so you can also check the complete solution in this lecture slides. All right, so, let's have a look at another example question. Find the exact solution of the equation log base 10 of x cubed minus log base 10 of 2 equals log base 10 of 2x squared. Okay, I'll give you 10 minutes to think about it first. Then we'll have a look at the solution together. All right, let's have a look at the solution together. The original expression is equivalent. First, we need to control the domain, right? So x cubed needs to be greater than 0, and 2x squared is also needs to be greater than 0. Then the left side is actually x cubed over 2, right? Right side is log base 10 of 2x squared. And this is equivalent. First, x cubed is greater than 0 means x is greater than 0. And the second is equivalent to x is not 0, right? As long as x is not 0, 2x squared is always greater than 0. So the third expression, this is equivalent to x cubed over 2 equals 2x squared, right? And this is equivalent to first two expressions can be combined to x is greater than 0. And next one, x cubed equals 4x squared, right? And this is equivalent to x is greater than 0, and x cubed minus 4x squared is 0, which is equivalent to x is greater than 0, and x squared times x minus 4 is 0. Therefore, this is equivalent to x is greater than 0. The second expression is equivalent to x is 0 or x is 4, right? By considering all these, therefore, the final solution is x is 4, right? We need to discard this solution here because x must be greater than 0. Okay, and you can also check the solution on this lecture slides after the class. All right, let's have a look at another example question. Find the exact solutions of the equation log square root of x squared plus 48x equals 1. Okay, again, I'll give you 10 minutes to think about this question first. All right, let's have a look at the solutions together. Okay, first of all, we need to use equivalent expressions, right? So first of all, we need to control the domain, which is the same as the rational expression. First, the domain is x plus 48x must be greater than 0, right? And of course, next, the original expression is equivalent to square root of x squared plus 48x equals 10, right? And this is equivalent to x times x plus 48 is greater than 0. And at the same time, x plus 48, x is 100, right? Okay, so this is a quadratic function which opens up and has two roots, minus 48 and 0. So this is equivalent to x is either less than 48 or x is greater than 0. And next, x squared plus 48x minus 100 is 0. And this is equivalent to x is less than minus 48 or x is greater than 0. And x plus 50 and x minus 2 is 0, right? And this is equivalent to x is less than 48 or x is greater than 0. And x is minus 50 or x is 2. So the final solution is x is either minus 50 or x is 2, right? Neither of these solutions violates the domain, so we can accept both of them. All right, so you can also check the complete solution on this lecture slides after the class, okay? All right, let's have a look at another example. Find the exact solution of the equation. 2/3 equals log base 10 of cube root of w squared minus 10w. Okay, I'll give you 10 minutes to think about this question first. All right, let's have a look at the solutions. Okay, first of all, the original expression is equivalent to, if you use the equivalent expression here, first of all, we need to control the domain, right? Domain is, the expression here is required to be greater than 0, right? And next, note the right side can be expressed as log base 10 of w squared minus 10w to the power of 1/3, right? And this is equivalent to, first of all, w squared minus 10w is greater than 0. And then 2/3 equals 1/3 times log base 10 of w squared minus 10w. And this is equivalent to, first of all, w times w minus 10 is greater than 0. And then log base 10 of w squared minus 10w is 2, right? So note here the first is a quadratic function, which has 2 roots and opens up. 2 zeros are 0 and 10, right? And when w is less than 0 and greater than 10, the expression is greater than 0. So the first expression is equivalent to w is either less than 0 or w is greater than 10, right? And next, w squared minus 10w is 100. Okay, so actually we don't need to write like this actually. Let's rewrite it here. Okay, so all right, so first expression w squared minus 10w needs to be greater than 10, right? Let's just copy this, and next w squared minus 10w is actually 100, right? So as long as w squared minus 10w is 100, of course, it is greater than 0, right? So this is equivalent to, we can just eliminate the first condition here. So this is equivalent to w squared minus 10w minus 100 equals 0, right? And then we can use the quadratic formula to find the solutions. W is 10, negative or positive 100 plus 400 over 2 equals 10, positive or negative 10 times square root of 5 over 2. And the final solution is 5 plus or minus 5 times square root of 5, right? Okay, and you can also check the complete clean solution in this lecture slides. Okay, so these are the techniques that we have learned for today, and let's make a summary. So today we basically talk about how to solve logarithmic equations and how to solve problems that involve logarithmic equations. Okay, we have used these example questions to illustrate the common techniques we can use to solve logarithmic equations or problems that involve logarithmic equations. So now the rest of the time is for you to complete and submit today's homework. Okay, you can start now, and do remember to submit them before the deadline. All right, so class is over for today. I'll see you next lesson. Okay, so I'll see you next lesson.